Step 1. Boot QEMU VM and disable driver signature enforcement. So, here I will execute this command that will start the QEMU VM. Please note the device option that I used here to add a pci-serial device. Now, I executed the command and the Windows 7 is going to boot. Please note that the VM has a 64-bit Windows 7. The boot process may take some time, that depends on your computer capabilities. Now that the system started, I will close this NAG activation screen. To disable driver signature enforcement, I will need to reboot the system and press F8 during the boot process. During the boot, press F8 multiple times. Now that I got this advanced boot options menu, I need to choose the disable driver signature enforcement option, and press enter. Now Windows will allow me to load digitally and sign drivers, and drivers having bad or untrusted signature. Now, I will execute the AMI admin tool, that will allow me later to control the VM accurately. As you can see, I have difficulty to control the mouse cursor of the VM, because the cursor does not point to the exact location. The tool is important here because it will allow me later to control the VM accurately. Step 2. Download the driver source code folder. To download the source code folder, first, I will access the link to show you the folder. I wrote down the steps needed to compile the driver using WDF 7.1.0. In this video, I will follow these steps. I will copy the GitHub link, and paste it in the down Git online tool. The tool will download only the specific folder of this driver for me. Click the download button and open the archive. Extract the archive into your working directory. Step 3. Set up a build environment. Now, I will open a terminal. Change directory to the extracted source code folder. Execute the set-env script with the given parameters. We need to change directory again to the source code folder. To build the driver, execute the build command. I made a mistake here. I will figure it out. I will open the terminal again. Can you see the difference? In fact, the issue was that I put the source code folder in a path having spaces. There was a space instead of underscore in the working directory file name. Now, I will build again. The driver was built successfully. Now, I will copy the .pdb and .sys files to the package directory. The package directory is a directory that will hold all files that I will need to transfer to my Kima VM later. Now, I will copy the .ctl and .inf files to the package directory as well. This folder is present in the WDK 7.1.0 and contains the Trace View tool, that I will copy to the package folder too. You can give a meaningful name to the folder if desired. Go back to the terminal, and change directory to the package folder. I will generate the TMF file by using the trace pdb command. This file will be needed by the Trace View tool later. Now, I will open the AMI admin tool and connect to the Windows 7 QEMU VM. Here I just tried to connect multiple times without success. I may need to close the tool in the VM and reopen it again. Now that I reopened the tool, I will try again. Well done. The connection was successful. I will change the screen resolution just to make it larger a bit. Now, I will transfer the package folder from my computer to the Windows 7 VM. The operation is simple, just select the folder and click the transfer button. The first thing that I will do now, is to run the Trace View tool as administrator. Click File menu, then Create New Log Session. Click Add Provider, then choose CTL file, and choose the CTF file of the driver that we just compiled. Click Select TMF Files, then choose the TMF file that we generated. Click Done. As you can see, the Trace View tool is now waiting for events. Now, follow these steps please to install the driver. Click on the Device Manager. You should see an unknown hardware device, which is the serial PCI device that we added via the QEMU command line. Right-click it, and click Update Driver Software. Click the Find Driver in My Computer option. Choose the Package folder. Click Install. The driver now was installed successfully. We can ignore this message. As you can see here, I have the hardware ID. Now, you can see that I received WPP tracing events in the trace view. WPP stands for Windows Software Trace Preprocessor. You can now stop tracing. I have received events for the driver entry routine, for the EVT driver device add event, and for the EVT device prepare hardware event. You can also see that the device provides two base address registers, a port base address register and an interrupt base address register. So, that was the objective of this video. I demonstrated how we can find the base address registers for a PCI device.